So welcome to Vortex Garage. I figured I'd go ahead and grab the camera and do a quick video here, talk a little bit about some sealed beam headlights. Now if you saw our last update video, which we talked about our restoration progress on the Triumph Spitfire, kind of toward the end of it, and I know it was a long video, but toward the end of it I talked a little bit about the headlights that came off the car. Well, I figured I'd go ahead and get the cameras out, show you a little close-ups of those, talk a little bit about them, and then generally talk about testing old sealed beam headlights and some of the pitfalls that you might find. Let's go ahead and kick things off and talk a little bit about the headlights we took off the car, because I've learned a little bit of more information since that last video. So first, I got them off camera here in a safe place. I'm going to grab the one that I was most excited about. This is a Lucas sealed beam headlight, and I have reason to believe, I hope, that this is one of the original ones to the car. What I'll do at the end of this video, I'll do a quick set of close-up views or take some macro pictures with the camera and post those at the end of the video. Just some of the markings that are on the bulb, because I know there's some folks out there who, again, are a lot more knowledgeable on these cars than I am in terms of what's original. So I am curious to find out if that's the case, but this does have the Lucas symbol and name right in the center. It's got a number 2 at the top, sealed beam across the bottom. It has a 249 with an S, looks like 13 right here, and it does say made in England on the front glass. On the back side it has a couple ink stamps. This one's hard to read, but you can kind of see behind it where the ink stamp was, and it basically appears to say British sealed beams, or sealed beams, and the numbers are a little hard to read, but the bottom number there, it looks like, I thought it was an 8, but I believe it might actually be a 6012. It's either an 8012 or a 6012. There's another ink stamp which I'll show you later. It says uprated, voltage tested, which I assume means that it's tested above 12 volts in case you have a faulty generator, regulator, or something like that that might overvolt your headlight for a little bit. It's tested to go a little higher so it won't burn out immediately. That's what I'm assuming that means. I could be incorrect. All right, so this is the Lucas bulb that we pulled off. Pretty interesting. Now the other one that we had looked at yesterday, or last update, it was technically yesterday. Or was it the day before? Doesn't really matter. But anyway, that one I mentioned may have looked like a General Electric, because it had kind of a circle logo down here. It was a little hard to read. Well, as soon as I shut the camera off, I went back and looked at it. It's not a General Electric. So this is actually a tongue sole headlight. It's got a TS in there, which we'll zoom in and show. So I looked it up. Tongue sole, TUNG-SOL, which stands, I guess, basically like tungsten and sol, like the sun or solar, is a Canadian company that made sealed beam headlights. They also made vacuum tubes and various other sealed electrical equipment of that ilk. And from what I understand, I believe Tongue Sole was owned at one point by Studebaker in the early 60s. They did make some OEM headlights. I think they made some headlights for Ford, probably a few others. They were a popular aftermarket brand that you could go buy at the parts store, which is what I believe this is. This isn't original to the car. I'm pretty sure it would have had 2 Lucases. I don't know if there would have been difference from left to right from the factory, because the left-hand drive, if they would have had different sealed beams from the factory, but to work with the US roads, and left-hand drive over here. But at any rate, I do know you could buy tongue soles aftermarket. That's what I'm assuming this is. And I know that I believe the tongue sole headlight arm was eventually bought up or sold by Wagner. I don't know if Wagner owns the whole tongue sole brand at this point, because I'm pretty sure tongue sole still has a website, and I think they still sell vacuum tubes, which you use in high-end amplifiers, musical equipment, stuff like that. So anyway, Tongue Sole is the maker of this. I believe Wagner eventually took on their headlight business, and you can still buy Wagner sealed beams today, though they're getting a little harder to find. So that's what we got with this headlight. So I then realized I had a couple other headlights from the other parts car that we have, which we got our powder-coated frame from. And I went ahead and fetched those to check out what those are, because I couldn't remember. And I got one of them here, one on the bench, one here. These are both General Electrics. They're just regular GE sealed beams. Pretty confident that these are, obviously aftermarkets. I would peg these as possibly even being in the 80s that these were installed on the car. So nothing too special with these. So what I elected to do next was, well, the big question was, are these headlights still working? I can see through the glass that the filaments looked intact, but would they actually work when voltage was applied to them? So we're going to talk a little bit about how to test these, some pitfalls of testing them, and whether or not an old sealed beam will work. Because there are a lot of people out there who are looking for, NOS headlights, they're looking for concours level restorations. They literally need to have the exact bulb that came off from the factory. And a lot of times those bulbs have to work. The equipment on the car, it's not just for show. You have to show that that headlight's going to light up. So one of the first things I'm going to cover, I'm going to set this down off camera, but one of the first things I want to cover is testing the bulbs. And some people, if you're already aware of this, you've probably seen it behind me. Yes, this is a battery charger. And no, a battery charger is not the item that you really want to use to test whether a sealed beam headlight works. The main reason for that is that a lot of battery chargers, you don't know if they're fully regulated. You don't know if they're manual or automatic, or you definitely have to know, because you could get into a situation where you switch it to 12 volts and that battery charger outputs more than 12 volts. It pumps out 14, 16, 18 volts, even just temporary, where it's not regulated and it jumps up. So you really have to be careful with that, because that's a quick way to overvolt your sealed beam headlight and blow it out. So really the best way to do it is with a 12 volt battery. Now with that being said, I've got batteries right over there, and here I am with a battery charger hooked up. Well, the reason that is, I've tested this battery charger, and it does output a steady 12 volts, and it did not fluctuate during tests with nothing hooked up to it. And as you can see, I've rigged up my multimeter onto the back of this headlight so I can actually monitor how many volts are going to it as I'm testing it. I'm also just testing these quite temporary, just a couple seconds here or there. But the big reason I'm using this battery charger is it has a 6 volt selector. So I'm actually starting off the sealed beam headlights to see if they work on 6 volts, just to see if I can warm them up. It's probably not really helpful or valuable, but the idea is that I'm going to start them. These things haven't run in so long. I'm going to, instead of shocking those filaments with a full 12 volts in the heat of that, I'm going to hit them with 6 volts. Maybe warm them up a little bit. Maybe that helps, maybe it doesn't, but hey, whatever, that's what I'm trying. So now that being said, applying 6 volt isn't going to prevent you from smoking a headlight. And as you might have seen when I held this one up, this one's a little foggy compared to this one. This one started to smoke, and it still works, and I'll show you kind of what it does as it heats up, and we'll talk a little bit about why it does that. So the big issue with an old sealed beam headlight that you're going to find is that headlights have to work in a vacuum. These open filaments, if there's oxygen on them, they'll oxidize and they'll burn out pretty much immediately. So these are built to operate within a vacuum. Now the issue that you're going to have is the sealing of the glass. Okay, when these originally were shipped, these were fully vacuumed inside. The big issue that you have is not necessarily air seeping in through the glass. The glass is pretty sealed. Even where it comes together, this is nice and sealed. The big issue you're going to have is at the actual connectors. And this one you can see is pretty nasty. It had stuff on it, it's just aged. Well, these connectors go into the glass, and like anything else, they have rubber seals or some kind of sealant or gasket around them. And over time, that gasket's going to erode, it's going to get brittle, it's going to crack, and it doesn't take much. I mean, you're just talking about oxygen and air getting in and equalizing the pressure where that vacuum is. You get a little crack in one of these, just enough. Over the course of a couple years, you're going to have that pressure difference equalize. You're going to end up, this thing's full of air. So the quickest way to know is apply voltage to it. After a little bit, it starts smoking. That means whether there's just a tiny bit of air or oxygen in there, or a full amount, that it's totally leaked, it's going to burn out pretty much right away. So you can definitely read stories of people with boxes of NOS headlights, and they pull them out, hook them up, and burn 50 to 60% of them. Maybe they burn all of them. Maybe they don't burn any. But pretty much when you go to get an old sealed beam headlight, you don't just want to do a connectivity test. Or a continuity test. You actually want to apply voltage to it and see if it's going to burn out. So let's talk about that a little bit. So continuity test is essentially, let me just flip this one around and show you. I've got things hooked up here. This would be our prongs to our battery charger, which isn't plugged in or turned on. And this would apply your 12 volts or 6 volts, whatever I have it switched to. And then I have these alligator clips hooked to it. This is kind of messy, but that's all right. I'm going to disconnect those for the time being. We'll show you testing these a little bit. Okay, move this out of the way, grab my multimeter. Now you're probably aware of this, but it doesn't hurt to show the difference between continuity and testing the actual voltage. So the continuity test, you'd set your multimeter to ohms. An open circuit, this is probably hard to see on the camera, it's going to be a 1 on your digital meter. You put these together, you've made a circuit, it's going to drop to 0. Okay, and it has on the screen there. So to test the continuity, you're basically testing to see if that filament makes a circuit still, because it's going to have to make a circuit to pass current. So you want to find your ground, and the easiest way to do that, if you look through the glass, you'll pretty much see, because you have 2 filaments, at least these bulbs do. If you have a dual filament, you'll have the 3 connectors. Okay, so you look through it, and there's one of the arms that comes out to a connector, and it has 2 wire runs to it. That's most likely your ground, because the 2, it's going to have a shared ground, and then you have your power for the upper filament and lower filament, your low beam and high beam. So you just come along, hook your ground up to your ground, and hook up to one of your filaments and check it. We went down to 0. All right, so that filament is good. It passes the continuity test. The other filament, same deal. All right, so both these filaments, even though this one started smoking a bit, they haven't burned out yet. There's still a connection across that filament. If you've ever taken a light bulb that broke and shook it, and you hear stuff rattling around in there, that's the remnants of the tungsten filament that's snapped and broken and is rolling around inside the glass. That wouldn't pass a continuity test. That's a hard word to say, don't you think? So anyway, that's the continuity test. And a lot of times what you'll hear, people will go to a swap meet or whatever, find an original headlight, whip out their multimeter, the seller has one there, they do a continuity test, everything's great. They get it home, they plug it in the car, they turn it on, and it smokes immediately. The reason for that isn't that the filament was ready to burn out, it's that the filament was exposed to air and oxygen specifically. That the vacuum had come away from the sealed beam headlight. As soon as you applied electricity, you had that oxidized filament, you had the oxygen in there, it reacts, it just burns it out immediately. So the only way to know for sure when you go to a swap meet and buy a sealed beam headlight, or you want to order one, you have to get assurances that it was tested with voltage and that it actually ran for a little while, didn't burn up immediately. Now if you get one and it does work, if you want to prevent from losing the vacuum, come along with a little bit of RTV and go around each one of these connectors where the gaskets is and try to reseal them. And that should help maintain that vacuum. As these continue to age, you're going to have that new RTV sealant around them to keep these sealed. So that'll be helpful. All right, so what we're going to do, I'm going to put this one back down on our carpet there. I am going to set this back up. I'm going to turn this back to volts. And we're going to get everything hooked up here, and we're going to test out this headlight that I know works. I'll bring the camera a little closer so you can see that, so I'm going to take a pause. I'm going to get everything set up here, and we will give that a go and kind of show you this one working. Then what I'll do, I'll show you the one that isn't working and how it can look. And then, I think from there, if everything looks good and we're not overvolting stuff with this charger, I'm going to try out the tongue sole and then the Lucas. All right, so we've got one of our General Electric sealed beams hooked up. We have our little test leads that come off the prongs as well. And we're going to go ahead and test it out. So as you can see, we've got our multimeter here. This isn't an auto range one. This is just a cheap little one. So we got it set to max 20 volts on the scale. So got our charger plugged in. Again, don't really want to use a charger, but I validated this is a fully manual charger. And I can keep an eye on the volts that it's kicking out here. So we're going to start with 6 volts on this one, which again, don't know if it's helpful, but figure I'm not going to shock that filament. And we're going to monitor on our multimeter here. Okay, so with the load of the headlight, looks like this thing's cranking out about 5 volts. And that's enough to get a little light on the headlight there. Still nice and clear, no signs of smoke. Let's switch it to 12 volts. Okay, and looks like about 10 volts are reading on the multimeter, which is a little hard to see with the light there. It's affecting the white balance. All right, but everything's good. Okay. Let's unplug our charger just to be certain we don't have any voltage going to it. I'll come around back. What I'm going to do is carefully move our test leads to the other filament. Now you want to be real careful on the connectors here when you're doing this, that you're not touching and grounding out. So we are good. This one will set up a little more like that. All right, so this will beam right into the camera pretty much. All right, let's plug our charger back in. Everything looks good on our multimeter. Let's try out our 6 volts. All right, there we go. We're reading 5.26, 5.27 on the multimeter, so not overcharging. All right, let's go to 12 and 10.2 on that. A little hard to see again. All right, but that's a good bulb, and I've left it on for a couple seconds. There's nothing going. I mean, like I said, if these have lost their vacuum, they're pretty much going to burn out immediately. All right, let's unplug that. I'm going to go ahead and reset. I'm going to hook up the one that smokes a little bit, and we're going to zoom in even tighter and show you what happens with one of those. All right, so we're zoomed in close here and got our battery charger plugged in. I'm going to go to 6 volts first, and let's see. What you're going to want to look for is some white smoke. White smoke's going to come off the filament, and it should rise up to the top here. So you should see it kind of around this area. So let's take a look and see. See that smoke in there? Okay, I'm going to shut her right down. Let's go to 12 volts, and it'll burn out quicker. There it goes. It actually just burned out right there. So that's unfortunately what happens when you lose vacuum in a sealed beam headlight. So what we're going to do, I'm going to move this to the other filament. Again, this is an aftermarket bulb that I just don't care about. If the Lucas one was doing this, I'd probably not even continue. All right, looks like we can see it there, so let's carefully do this. All right, we'll try 6. All right, you can see the smoke in there. Let's again give 12 a try. You can really see the smoke as it oxidizes. All right, I'm gonna go ahead and shut it down. And you can see, let me zoom out a bit. Let it focus. You can really see up here, this is actually, deposits on the back of the glass. It's really fogged at this point. And again, I saw we weren't overvolting. So it wasn't an overvolt problem. This was a lack of seal in the headlight. All right, so you might be wondering, if you have a headlight like this and it's not sealed, it's some very special, NOS headlight that you need to use for concours, are there any options? What can you do? Well, there's a couple things you could do. You could know that it's going to burn out and just come in here with some glass cutters, remove the back piece, and you could put in a modern type bulb and run it. But obviously, if you're looking for concours, if they can spot that in there, that's probably not going to help you. The only other thing you could really do is there is a piece on the end here, which we'll zoom in. You'll see it in some of the close-up shots. It's basically from the factory where they drew a vacuum on the glass, and then as it had a vacuum, they heated up this tube and pinched it shut, and that locked in the vacuum in here. So what you'd have to do is cut that back open. You'd have to connect a tube up to it, vacuum it out, and then somehow heat that and repinch it. So you pretty much have to enlist the help of someone who has glass making capabilities. So I suppose if it was a super valuable headlight, you could have it repaired in that sense. I mean, everything is repairable. The big question you have to ask is, number one, is it worth it? And number two, can you not just go buy another one for cheaper? So, again, I guess that falls into the is it worth it category. But so I think that's just the way it goes though. I mean, these either have good vacuum and they're usable and you can go ahead and seal them up and hope to get a little bit of more life out of them, or they're pretty much going to burn up right away. All right, so we know what we're dealing with here. So now here's the tough part. I'm going to hook up the other two headlights we have. I'm just going to test one of the filaments on each because we know if they're losing vacuum, they're going to burn pretty quick. And we're going to do the tongue sole and then the Lucas and see if those are working headlights that still have good vacuum. All right, so we got our tongue sole bulb hooked up just to one of the filaments. We're going to flip the switch on 6 volts and see if we get any light out of it. And we've got light and no sign of smoke. Everything's nice and clear. And we're showing good voltage on our multimeter there. All right, let's switch to 12. Ooh, it's a nice bright light. That's actually quite a bit brighter than the GEs. At least it seems that way to me. Probably how I'm sitting. All right, so that one's good and didn't overvolt. All right, so our tongue sole's working. Let's go ahead and give the Lucas a try. All right, so we got our Lucas bulb hooked up and ready to go. But real quick, I'm going to switch it over to our continuity test, and 0 ohms, so we're good. So this one should work. The big question is, this Lucas bulb lost its vacuum and going to smoke. Okay, here we go. Let's start with 6 volts. Looking good. Got light, no signs of smoke whatsoever. All right, let's give 12 a try. Another nice and bright light. I think it's the way I'm sitting. I think I'm sitting right in one of the focus points. All right, so that's good stuff. Our Lucas beam is working. We've got connectivity across both filaments. So I'll tell you what, let's do it real quick. Let's move to the other filament and see if the other one works. It's called pushing your luck. That's what I'm doing. All right, this is the other filament test, 6 volt. Okay, voltage looks okay. We're not overvolting it. Let's try 12. Same deal here, we're not overvolting it. No sign of smoke whatsoever. All right. All right, so I hope you enjoyed our video here, and it was definitely cool to see this old Lucas headlight still works. It's still got vacuum, and it's still functioning sealed beam. Also pretty cool, our old tongue sole there, which is probably a vintage aftermarket replacement, was also still working. And like I said, we'll take some time at the end of this video, do some close-up views of the markings on these headlamps for you to check out. So, you know, if you're the kind of person that would like watching a video on YouTube of close-up vintage headlight markings, well, you'll definitely enjoy it. I know I would. So anyway, I hope you also enjoyed our discussions about what to look for in these old sealed beams and how to test them, and now know that, you know, if you're buying one at a swap meet, don't just rely on that continuity test. You actually want to do a voltage test, that if these lose their vacuum, get oxygen inside, you're pretty much going to toast that filament right away, even if it passes that continuity test. Also, we'll probably go ahead and take a little RTV around these sealing pieces here on the connectors, since these are good, and hopefully that'll help them keep their vacuum for many years in the future. So anyway, important point, just a reminder, battery chargers. I know we used one here, but not the best way to test these. If you're going to do it like I did, have your multimeter first validate that it's putting out a pure 12 volts. It's not an automatic one that's going to upvolt. It's not unregulated. And I only did it for a couple seconds. Really, battery, the best way to do this. But I did like having the option of putting 6 volts through it. So at any rate, again, hope you enjoyed this video. We'll keep them coming, and thanks for watching.